Welcome to the project demonstration of bidirectional power converter for electrical vehicle with charging feature and smart battery management system. Here we have the two features. One is regenerative braking and also with the bidirectional power converter to charge the battery and take the power from the batteries and the motor. When we switch off the power to the motor, it will act as a flywheel. And that will be given through this bidirectional power converter to the battery, and we are going to measure the voltage. So this is called as a BMS, battery management system, and measure the voltage from the dynamo. It will act as a flywheel and that will display on this LCD, and the battery voltage is also taken from this voltage sensor and displayed in this LCD. And when the voltage of the battery is less than 23 volts, then here we have given one switching circuit, that is a relay, and when the battery is less than 23 voltage is less than 23 volts, then the relay will be switched on and will charge from this dynamo. And this is the electromagnetic relay to allow the power from the generator to the battery. And also we have one more source, the transformer grid. So from this transformer we are going to charge a battery whenever there is no power generated from this generator. So here we are using PMDC motor, which will act as motor as well as generator. So when we apply the brake, that will display the power supply to these batteries. And here we are having one indication of light LED. Whenever the brake is applied, it will generating the power and giving to the batteries. And when we apply brake to this motor, it will act as like a generator, and when we give power supply to this motor, it will act as like a motor. Now it is a motor, and when we switch off the power supply, it is applying the braking and it will act as a generator and giving the power supply to the battery. And to give power supply to this to this battery, instead of this generator, we are using one transformer grid, and here we are using IP107 IC version of full rectifier, so which will convert the alternate current into input of DC, and that DC is converted here to filter DC and give it to the boost converter, and the power supply is given directly to the batteries. This 24 volts 3 amp battery, and this power supply is used to run this motor. And from this, when it is act as a generator, means when the brake is applied, it will act as a generator as we discussed. And when it is act as a generator, here we are using one charging circuit which will convert this generated power, and it will see the polarity. It will act as like a polarity corrector, and it will filter the fluctuations and give it to the batteries. And here we are using one transformer which will step down the voltage from 230 volts to 24 volts. Why? Because here we are using 24 volts 3 amp battery, so we want to charge with 24 volts, and we are here giving to this IC version of full wave rectifier, full bridge rectifier, and this will give the DC supply to this batteries to charge the batteries, and the power of the batteries is monitored in this LCD display by using this PIC16F72 microcontroller, and that is taken from by the using voltage sensors. One voltage sensor is used to take the generated power and display the generated power in this LCD, and another voltage sensor is used to monitor the battery voltage. When the battery voltage is less than 23 volts, then automatically the PIC16F72 microcontroller will switch on the relay, electromagnetic relay, and will allow the supply from this generator to the battery. And let us see the demonstration. And first, for seeing the demonstration, here we want to connect this adapter to the power supply, and we can see here the generated voltage is 0 and battery voltage is 23.9. when it is less than 23.9 volt, then it will the microcontroller will allow the electromagnetic relay to flow the supply from the generator to battery. And let us see the demonstration. And now I am switching on the circuit, which now this motor will act as like motor. Now it is working by this battery supply. Now I am switch off in the circuit, means now I am applying the brake. Now we can see the output voltage is generated from this generator and giving it to the batteries. Now the battery voltage is 23.9 volts, 3.79, and now I am just removing the input from voltage sensor, battery to voltage sensor to microcontroller. When I remove, the battery voltage is 0, and now we can see the relay is switched on and it is giving power supply from generator to the battery, and when the generator voltage will be given to directly to the battery.